This entire chapter, chapter 11, is of course devoted to the largest planet in the solar system, Jupiter. There's a nice picture of it showing the zones and the bands. We'll talk about those in a little bit. And of course, one of the most probably famous feature of Jupiter is the Great Red Spot, which we know has been around for at least 400 years, probably a lot longer than that. Actually, recently it's been shrinking. That's just a little point of interest. We're not really sure why. The structure that we see on Jupiter, so this is our first gas giant, of course, the first of the four gas giants, and of course the largest. The thing to know about the gas giants, I should start off with right away, is that there is no surface, right? It's not like, Mars or Earth or even Venus, although you don't want to be on the surface of Venus because it's way too hot, or even Mercury. There is no surface. It's basically clouds, and the clouds just get thicker and thicker and thicker as you go towards the center. As we're going to talk about in a little bit, the center of Jupiter, the core of Jupiter, might actually have metallic hydrogen in its metallic form. All right, so these are some of the things that we're going to talk about. There's the internal structure stuff that I was just talking about. There was a very famous impact comet that broke up and impacted the surface of Jupiter in 1994. I actually saw that I was working at the University of Alabama at the time. And it was a pretty amazing summer to witness that. When it actually happened, we had no idea if we knew ahead of time that this comet was heading towards Jupiter, but we had no idea whether we'd be able to see anything. And there were large, dark scars on the surface of Jupiter. All right, we'll talk about the rest of this stuff. The moons of Jupiter are very, very interesting. All the gas giants, I should mention right here, all the gas giants, of course Saturn being the most prominent, but all of them have rings. So, and Jupiter has a very strong, very, very strong magnetic field. It's actually only the second strongest magnetic field in the solar system, second only to the sun. All right, so of course Jupiter is the fifth planet from the sun. Between Mars and Jupiter, there is a region called the asteroid belt, and beyond the orbit of Neptune, there's a region called the Kuiper belt. There's actually a whole chapter on the asteroid belt and the Kuiper belt and the Oort cloud. We'll get to that much later. I think it's in chapter 14. All right, so let's just stick with Jupiter for right now. All right, so let's see. So here's some different views of Jupiter, through different telescopes. Some, telescopes that are actually in space. All right. This Cassini spacecraft was actually on its way to Saturn and took some pictures of Jupiter. We've actually had spacecraft orbiting Jupiter. In fact, right now, depending on when you're watching this, there's actually a spacecraft that is going called Juno that is actually orbiting Jupiter, and it's actually going in a north-south orientation. The last spacecraft that we had that orbited Jupiter, and it orbited Jupiter for many, many years, was called Galileo. That gave us tremendous amounts of information about Jupiter and its moons, which, by the way, Jupiter, being the largest planet, also has the most moons in the solar system. All right, there's its mass. As it says, if you added up all the mass of all the other planets, including Saturn, which is a pretty massive object, the mass is twice as much as the combination of all the others. So and it's also, notice how big it is, over 71,000 kilometers. It's almost a little more than 11 times the mass of, the size of the Earth. Notice its density is actually closer to that of liquid water. I'll remind you that liquid water has a density of about 1. If we turn this into grams per cubic centimeter, which we usually do, Jupiter would be about 1.3. So it's, rocky material is generally has a density of about 3.3 or so. Like for example, the Moon has that density. The Earth has a density of 5.5, as we've talked about in the past. And so that the Earth has rocky, silicate-based rocks, as well as heavier stuff like iron and nickel in its core, and so that's why the overall density of the Earth is higher. So Jupiter does not have such things. We do think that there is metallic hydrogen at the center just because of the enormous pressure of the gas at the center. So of course, because, and this is true for all the gas giants, when we look at Jupiter, we see the outer atmosphere, and remember, it's just atmosphere. The further you go into Jupiter, the thicker the atmosphere is. So it rotates not as a solid body, but there's really different rotational rates for different parts of Jupiter. If you go by the magnetic field, which is a very strong magnetic field, if you just look at the magnetic field that's sweeping around Jupiter, as Jupiter rotates, the period is a little less than 10 hours, and that's generally actually when you look in textbooks and so forth, and they say what's the rotational rate. The rotational period, I should say, of different planets. Generally, they'll quote the rotation of the Jupiter's magnetic field. All right, there's of course the Great Red Spot, at first seen by Galileo. Actually, Galileo didn't really understand what he was looking at. He had a pretty weak telescope certainly by today's standards. I mean, just a small telescope you could buy in a hobby store that cost maybe $100 or so gives you much more detail about the Great Red Spot than Galileo ever had. But remember, he was looking at this thing 400 years ago. The Great Red Spot is so big you could actually fit the Earth inside of it. It's gigantic. The surface features, not surface, or the atmospheric features that we see are called zones and belts, or zones and bands. Sometimes they're called as well. The zones are cooler, and they're also brighter. And they're higher. They're physically higher. This graph or this picture here shows this a little bit better than the belts, or sometimes called the bands, like I just said. What's interesting about them is this is a very stable form of gaseous flow. That's actually kind of important when you're trying to model, what's going on in the atmosphere of Jupiter, which turns out to be really complicated, much more complicated than any of our mathematics can predict. There's some chaos going on as well. This is actually an interesting picture of what's going on with the wind. Notice in some directions, it's moving. Like just looking at this picture, some directions are moving to the right. Some winds are moving to the left. So there's not this overall rotation the way that we have with the terrestrial planets, the Earth-like planets. All right, and All right, so we're just talking about the atmosphere right now, but one of the things that we're going to find out about Jupiter in particular is that there's actually, it gives off more energy than it receives from the sun. And that's, we'll talk in a little bit more in detail about that when we talk about the internal structure our model for the internal structure of Jupiter. All right. So the atmosphere is mostly hydrogen and helium, mostly hydrogen, and then second comes helium. There's the coloration actually comes from the small amounts of methane and ammonia, and there's even water vapor in the atmosphere. And so we think that there's some kind of chemical interactions going on with the sunlight and these different molecules to account for the colors. All right, and that's still a mystery for us. We don't know everything in science. That's why we continue to take measurements and to try to make models and come up with theories. But we certainly don't know everything. This is a model of the atmosphere from using the Galileo spacecraft. Remember that the Galileo spacecraft orbited Jupiter for over a decade, and it's actually gone now. Actually, that's an interesting little bit of a story in and of itself. One of the moons of Jupiter, in particular, the one called Europa, possibly has very strong evidence that it has a liquid interior inside of the moon and an icy surface. And there's always been the question, for the last 50 or so years, is since we've determined not 50 years, about 30 years or so, that we determined Europa had a liquid interior, and so perhaps life, even microbial life, little microbes, might exist in such an environment. And so when the Galileo spacecraft was finally, it was at the end of its mission, the scientists at the Jet Propulsion Laboratory in Pasadena, California, who controlled the spacecraft, decided, and I believe correctly, to actually just have the Galileo spacecraft crash into Jupiter, and it would just be crushed and be part of Jupiter, so as not to contaminate if there are any microbial life forms on Europa. We don't want to contaminate those things. All right, so we know that the Great Red Spot's been around for a long time, more than 300 years. Certainly since the time of Galileo. And probably, it's been around for thousands upon thousands of years, maybe tens of thousands of years, according to some estimations. It's very complicated, the motion that's going on with right around the Great Red Spot. There's actually these little white spots sometimes. It doesn't stay the same. The atmosphere of Jupiter is changing all the time, and so sometimes we see these darker features, and we just gotta observe these things. These are these little white spots as well that sometimes get whirled around the Great Red Spot. Remember, these are all atmospheric features, and pretty much what we do now is just observe and record, what's going on. It's really hard to predict anything because a lot of this stuff is again chaotic motion. All right, so I'll pick this up in the next video.